Hello everyone! For today's lesson, we're going to be learning about proportionality webs. Now what I have here for you is a chart of a proportionality web. There are 5 important parts that you need to know when looking at these types of webs. The situation, the rule, the table, the graph, and the most important part of these 5 points, the constant of proportionality. We're going to go over these 5 important points today, describing what they are and how you can use each one of these as you make your own proportionality web. So let's begin by looking at some of these important things. The first thing, and the most important, is the constant of proportionality. Now the constant of proportionality is just another way of saying unit rate. Now to review what unit rate is, a unit rate is when rates are expressed as a quantity of 1. So what I have up here, I have a quantity of 1 represented by 1 hour, and its rate is 10 miles. So the unit rate would be 10 miles, since you're comparing 10 miles to a unit of 1. It's the same thing over here. I have 1 unit of a candy bar, and its rate is $2. So the unit rate would be $2. So going back to the chart, when you write down your constant of proportionality, you are actually going to write either 10 miles or $2, since each of these rates is equal to 1 unit of an hour or 1 candy bar. The second term you have to know is called the situation. Now, so the situation is the word problem the unit rate comes from. So when you are trying to figure out your unit rate, it is the word problem or word story that the situation is involving. So for example, every 1 hour, a car can travel 10 miles. Instead of saying just 10 miles per 1 hour, it is actually put into a mini word problem. So every time a car would go 1 hour of driving, it can cover 10 miles. So if you were to take a look back at your chart and look at situation, you are actually going to write the mini word problem. So where situation is put, you would put every 1 hour, a car can travel 10 miles. The third term you have to know is known as the rule. Now the rule is an equation sentence using a unit rate to solve for other amounts, such as money cost, distance traveled, etc. Now how would you write the rule? I have 2 examples right down here that should give you more of a visual. So when they say a rule, it means an equation. So like y equals kx. Now if you take a look carefully at this one right here, this is a representation of this small equation problem right here. So I decided to use a little bit from the car problems from before. I had the distance is what you're trying to figure out, and take a look right here where it says unit rate. That's where your 10 miles would go. And then depending how long you travel, you put hours. So if you're figuring out a word problem, like every 1 hour, a car can travel 10 miles, you're going to write an equation. So you would have your unit rate, which would be 10 miles, and any number of hours you decide to travel. So let's say you decide to travel 8 hours. If you were to travel 8 hours, and you know that for 1 hour you're traveling 10 miles, you would do 8 times 10, and that will get you your distance. So when you represent your rule on your proportionality web, you're going to write the equation distance equals 10 miles and then any number of hours. And now we finally come to the last 2 terms you might be familiar with: table and graph. Looking for a little bit familiar right now? When you put the table on your proportionality web, you are literally going to make a chart. So thinking back to our car problem, where every 1 hour of travel gets you 10 miles. So I would represent this as 1 hour that I travel, I will achieve 10 miles. Now look what I put up here. I started off with 0, 0. Now why did I do that? Well, the answer is pretty simple. Every time you're trying to check for a unit rate, you would always want to start off equally. Now what I mean by starting off equally is this. Whenever you're trying to figure out a unit rate, you always want to start off with a constant of 0, 0. Because every time you would add a unit, like for example 1 unit for your unit rate, you would always want to make sure that these, when they get bigger, like 1 goes to 2 and 10 goes to 20, there is a consistent rise in their numbers. So a good example would be if you start off with 1 hour and you get 10 miles from that 1 hour, you want to rise equally. So that's why you have to keep that consistency of 0, 0. Because if you have 0 miles traveled, you're going to travel 0 hours. And now when you go up, let's say instead of 1 hour, I'll travel 2 hours. So my amount of distance must be consistent with that of how many hours I traveled. So since I travel 10 miles in 1 hour, I must travel 20 miles in 2 hours. Because 1 plus 1 is 2, and 10 miles plus an additional 10 miles will get me 20 miles. So now when you represent your table onto your proportionality web, right where it says table, you are literally going to put one of your charts on there, in that exact same spot. And finally we come to our last important step, graphing. Now this is where your table can come in very handy. So let's take a look at the graph that I put up here. I know that because I'm working with unit rates, I have to start off with a constant of 0, 0. So if I look down at my graph, just as it says here, I start off at 0, 0. Now, I also have to make sure that when I work with unit rates, the incline of the line on my graph has to be constant. It cannot be a whole bunch of little squiggles or a whole bunch of waves. It has to be a constant line going from 0, 0, which is at the bottom left, and slowly start to rise to the top right. If the line was going from the top left to the bottom right, that is not unit rate. That is not the constant of proportionality. And you have to keep that in mind. So, when we do our graph, we have our constant, 0, 0, which is down here, and then we find our constant of proportionality, which is our unit rate. And just like we said before with unit rate, it's any amount that is equal to a single unit. So for example, 1 hour, which is represented down here, you'll travel a distance of 10 miles. So I will go down to my 1 hour and slowly go up, and then, oh look, it matches up with 10 miles. So I know that every hour I gain, I'm going to go up an additional 10 miles each time. So going to here, for example, I went from 1 hour to 10 miles. Now I'm going to go 2 hours, which should equal 20 miles. Let's check. So I'll go down to my 2 hours right here, and I'll slowly go up, and look, it matches up with 20 miles. So now I know that this graph is displaying the perfect example of constant of proportionality. Because not only do my hours go up by a single hour at a time, I now know that every hour I go up, I gain an additional 10 miles. So there's a constant rise, and it is equally proportional, or constant. So now to add the final step to our proportionality web, I go to the graph area, and where it says graph, I am literally going to put this entire graph into that spot. So now we went through all the important terms. It is now time for the final reveal of our situation, our rule, our table, our graph, in our most important constant of proportionality and see what happens when we put each of their examples into their selective spots. You ready? Drum roll, please. Ta-da! This is what a proportionality web looks like when each step is added into their spots. So right over here is the situation. And just like we recalled, the situation is where you take your unit rate and put it into a mini word problem. Every 1 hour, a car can travel 10 miles. Our rule, as you see here, we put it into an equation. So the distance we travel is equal to 10 miles times the number of hours that we decide to travel. When we add our table or chart, you can see here that we have, like I said, that constant of 0, 0, our beginning, and our most important unit rate. So 1 hour will get you 10 miles, and as you keep going, etc., etc. Then finally for our graph, you can see I put my graph into that spot. And like I said, the most important thing to have on this proportionality web is the constant of proportionality, which is your unit rate, and it's right there. 10 miles. So now that you're a little familiar with how to construct your own proportionality web, I'm going to give you one example that you can do with your teacher in class and see how well you can apply all your known knowledge right now into your future proportionality web. Oh, it's that Willy Wonka and his Wonka bar. So here is an entire word problem plus a few instructions where now you are to take the information that you are given and turn it into a proportionality web. That means you got to have your situation, your rule or your equation, your chart or table, your graph, and your constant of proportionality. So if we were to look back at our word problem, Willy Wonka is about to sell his new Wonka bar. Now at opening day, about 30 people came in to buy said new candy bar, and after everyone bought a candy bar, Wonka made a total of $52.50. Now your mission in the next few minutes is to find the unit rate and to draw a table, a graph, and write the equation. So I'll give you a few minutes now to see if you can find and solve each of these steps. So now that you've had a little bit of time to look over this problem, find unit rates, and probably even touch upon one of these, we are going to look at the final results and plug all of that, like the unit rate, the table, graph, equation, and see how it looks on a proportionality graph. Ta-da! This is what happens when we take that Wonka candy bar word problem and turn it into a proportionality web. And that is how you make your own proportionality web using all 5 of these important steps. Have a great day!